Good morning, students. Let us continue with our lesson number 4. As I have told in the previous video that today we are going to see each and every three different representations which are used. So as here you can see that signed integer representation, that to represent zero, positive or negative integer, there is a three different representation schemes are used. This method are first is signed magnitude method, second is first complement method and थर्ड इज सेकंड कॉम्प्लीमेंट मेथड। तो जैसे मैंने आपको बताया था इससे पहले के वीडियो में कि नेक्स्ट वीडियो में हम लोग डिस्क्रिप्शन देखेंगे ये तीनों का, अगर ज़ीरो है या फिर पॉजिटिव है या फिर नेगेटिव इंटीजर है तो हम उसको कैसे रिप्रेजेंट कर सकते हैं। ओके, सो उसके लिए तीन मेथड अवेलेबल है यहाँ पे। तो फर्स्टली वी विल सी द signed magnitude method. In a signed magnitude method, a prefix 0 for indicating positive number and a prefix 1 to indicate negative number is used. यहाँ पे देखो साइंड मैग्नीट्यूड मेथड में क्या है कि अगर प्रीफिक्स 0 है तो वो क्या इंडिकेट करेगा, पॉजिटिव नंबर, और अगर प्रीफिक्स 1 है तो वो नेगेटिव नंबर कंसिडर करेगा। लाइक सपोज कोई भी आपका नंबर है, उससे पहले मीन्स बिफोर ऑफ योर नंबर if your digit is 0 then it will represent, it will indicate positive number, and if your number is 1 then it will indicate a negative number. That is, if number is minus 10 base, sorry, if number is minus 5 base 10 is to be stored into memory, first it is converted into its equivalent binary number which is 1012। यहाँ पे देखो एक एग्जांपल दिया कि -5 है, ठीक है। अगर उसको मेमोरी में स्टोर करने हैं तो सबसे पहले कन्वर्ट हम कैसे करेंगे, उसको कन्वर्ट करेंगे उसकी इक्विवेलेंट बाइनरी मेमोरी में। तो उसका -5 है, ठीक है। तो आप बाइनरी टेबल आपको पता है, तो आप बाइनरी टेबल में देखोगे फिफ्थ नंबर क्या इंडिकेट करता है, तो उसका आंसर क्या आएगा, विच इज 101 बेस 2। 2 मीन्स बाइनरी, दिस इज योर बाइनरी नंबर, एंड 10 मीन्स योर डेसिमल नंबर। The first bit is 1 and remaining bits are binary digits representing the number। यहाँ पे आप देख सकते हो कि आपका फर्स्ट बिट है, द फर्स्ट बिट इज 1, आपका फर्स्ट बिट जो है वो 1 है और रिमेनिंग बिट्स ऑफ द बाइनरी रिप्रेजेंटिंग योर नंबर। हाउएवर दिस मेथड हैज सम limitations. For example, the number 0 has two possible representation according to this method, like a positive 0 and a negative 0। like ये मेथड में दो possible representation है according to this method, that is positive 0 and negative 0। So now go to the next one, that first complement refers, first complement refers to be presented and to be presentation of binary number converting ones into zeros, vice versa। Here also one can get two representation, like 0, if there is a 8 zeros that means plus 0, and if there is a 8 1 that means माइनस 0। यहाँ पे आप देख सकते हो कितने जीरोज है, 1 2 3 4 5 6 7 8, और यहाँ पे भी आप देख सकते हो 8 1 हो गए, 1 2 3 4 5 6 7 8। ओके, सो अभी तक हमने दो मेथड देख ली है। साइन मैग्नीट्यूड मेथड में मैंने आपको बताया, अगर प्रीफिक्स आपका 0 है तो पॉजिटिव नंबर, और अगर 1 है तो नेगेटिव नंबर। अगर वो डेसिमल में है तो सबसे पहले आपको उसको कन्वर्ट करना होगा बाइनरी में, और उसके बाद आप पता लगा सकते हो। और फर्स्ट कॉम्प्लीमेंट में मैंने बताया आपको कि इन दिस number can be converted in the first into the zeros, vice versa। So in this also there is a two representation, like if your 8 bits is 0, that means plus 0, and if your 8 bit is 1, that means minus 0. Another method to represent a numbers into computer memory, the second complement method is very popular. यहाँ पे देखो नेक्स्ट मेथड है, अगर कोई भी नंबर रिप्रेजेंट करना है आपके कंप्यूटर मेमोरी में तो उसके लिए तीसरी मेथड कौन सी है, दैट इज सेकेंड कॉम्प्लीमेंट मेथड. वो पॉपुलर है अभी, इट इज़ अ वेरी पॉपुलर मेथड. सो in this method, it is similar to above mentioned unsigned integer representing expect the most significant bit. The most significant bit has negative value. In figure number 4.13 shows some example of representing using second complement. So in the second complement, it's like same as in the significant magnitude, that here you can see second complement, your first number is 0 1 0 0 0, your base is 2, that means this is the binary number. This is a मेथड ऑफ कन्वर्जन, कैसे आपको कन्वर्ट करना है वो यहाँ पे मेथड आपको बताइए. दैट 0 into 2 is to 4, 2 is to 4. रीजन यहाँ पे फोर्थ वैल्यू है, इसकी फिफ्थ वैल्यू है, दैट्स वाई. यहाँ पे देखो सबसे पहले मैंने इससे पहले आपको एक्सप्लेन किया था, आपको सबसे पहले देखना होगा कि कितने डिजिट्स है. यहाँ पे 5 डिजिट है तो 0 1 2 3 एंड 4. तो 0 into 2 is to 4, 1 into 2 is to 3, 0 into 2 is to 2, 0 into 2 is to 1 and 0 into 2 is to 0. तो सिर्फ सिंपली आपको यहाँ पे कैलकुलेशन करना है, बट यहाँ पे आपका फर्स्ट डिजिट क्या है, 0 है. दैट मीन्स योर नंबर इज पॉजिटिव. नाउ मूविंग टू द नेक्स्ट, दैट इज 1100. यहाँ पे देखो सबसे पहला डिजिट आपका है 1, दैट मीन्स द आंसर विल बी इन द नेगेटिव. मीन्स यहाँ पे आपका आपको जो क्वेश्चन दिया है, ठीक है, यहाँ पे आपका प्रीफिक्स 1 होगा, मीन्स प्रीफिक्स नेगेटिव होगा. तो यहाँ पे आप देख रहे हो सबसे पहले -1 है, -1 into 2 power 4, and simply they have calculated, and then after they have here they have minus as per the formula. So -16 plus 8 plus 0 plus 0 plus 0, it is -8 base 10. 10 means we have converted in the decimal. So here second complement number is given in the binary, we are converted into the decimal. So here in the next step also, next examples also, here you can see your prefix is 1. यहाँ पे आप देख सकते हो आपका prefix 1 है, that means it is a negative. So सबसे आगे क्या आएगा, minus. In the next there is also same, यहाँ पे भी 1 है, so that means this is the नेगेटिव प्रीफिक्स आपका 1 है, तो यहाँ पे भी माइनस आएगा. So sir, just simply you have to do the calculation. So this is the conversion of second complement number into decimal. The above table shows conversion of second complement number into the decimal number. To find a 2's complement number from a given decimal number, do the following thing. यहाँ पे देखो जैसे टेबल पर दिखाया, अगर आपको 2's कॉम्प्लीमेंट नंबर दिया गया और आपको डेसिमल नंबर फाइंड करना है तो आप फॉलोइंग चीज़ का यूज़ कर सकते हो. लाइक कंसिडर द बाइनरी रिप्रेजेंटेशन ऑफ अ नंबर, देन इन्वर्ट द बिट ऑफ बाइनरी नंबर टू मेक 0 और 1 एंड वाइस वर्सा. क्योंकि आप सबको मालूम है कि बाइनरी नंबर में दो ही नंबर रिप्रेजेंट करते हैं, 0 और 1. उसके लिए सबसे पहले आपको कन्वर्ट करना होगा. This is known as first complement number of a given binary number, and add 1 to it. Consider the decimal number 9 represented as 9D. यहाँ पे वो क्या कंसिडर करना है, सपोज द डेसिमल नंबर इज 9 represented as 9D, 9 number and D means decimal. The number can be represented in binary as 01001 B. B means binary and 01001 is we have converted 9 into the binary. For that you have to see the table as you know the table of the binary and decimal. Changing zeros to ones and vice versa make the number as 10110B. Adding 1 to make it 10111, which is minus 9. So it is to be noted that as n-bit second complement sign integer can be represented integer from -2n-1 to +2n-1 minus 1. तो उसके लिए आपको क्या करना होगा? You have to see the next page. You have to see the figure number 4.14. You will understand that how it is representing in -2 raised to n-1 and +2 raised to n-1 minus 1. So for that you can see here in the next table, you can see here the range of the numbers. यहाँ पे देखो numbers की range आपको बताई है. सबसे पहले number of binary digit mean bits 8. 8 means you have to count from the 0, 0, 1, 2, 3, 4, 5, 6 and 7. So here you can see -2 raised to 7, and this is the minimum number and this is the maximum number, that is plus 2 raised to 7 minus 1. So just you have to calculate it and you will get the answer. Same like this in the 16. So in the 16 you have to count from the 0. 0 से ही आपको हमेशा स्टार्ट करना होता है. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So -2 is to 15. After calculating, you will get the 32,768. And here you can see maximum number in that side plus 2 raised to 15 minus 1. जैसे इससे पहले हमने देखा था फॉर्मूला में that -2 n minus 1, like n यहाँ पे हमारा है 2. So you can see 2 raised to 2 minus 1. My 2 minus 1, that is 1. That's why we have kept the 2 raised to 7. Means number of binary is 8. Means you have to count from the 0th. Same like that in the maximum number side, you will do the calculation, then you will get the maximum number, that is plus 32,767. In the 32 bits, you have to count from the 0 and -2 raised to 31. After doing the calculation, you will get this answer. So this is the table of range of numbers in minimum number and maximum number which are storing in the computer. Moving to the next topic. Next topic is floating point number representation. What is the floating point number representation? First of all, to represent fractional number, floating point number representation is used. अगर आपको fractional number represent करने हैं तो उसके लिए floating point number representation use होते हैं. So this the IEEE 32-bit single Hessian method is commonly used to represent a real number. Hence, IEEE represents Institute of Electrical and Electronics Engineers, which is world's largest professional association dedicated to advanced technology, innovation, and excellence for the benefit of humanity. So you can see online also in www.ieee.org. According to this method, representation of a given number is divided into three parts as shown in figure number 4.14. यहाँ पे आप देख सकते हो कि ये जो मेथड है उसके लिए सबसे पहले नंबर को आपको this is divided into three parts, that is sign, exponent and fraction. Like suppose here you can see sign means 31 means 1, and after exponent means 30 to 23, that means 8, like 23, 24, 25, 26, 27, 28, 29 and 30, that means 8 number. साइन मीन्स सबसे पहला नंबर, उसके बाद के जो 8 डिजिट आपके होंगे वो होंगे होंगे आपके एक्सपोनेंट एंड उसके बाद के जो 23 होंगे वो होंगे फ्रैक्शन. दैट मीन्स 0 to 22, दैट इज योर फ्रैक्शन. तो दिस इज द IEEE 32-bit single precision floating point number. So here you can see that the three parts are given below. The first is the most significant bit is the sign bit with 0 for negative number and 1 for positive number. यहाँ पे देखो ये आपको इम्पोर्टेंट पॉइंट है, ये आपको ध्यान में रखना है कि यहाँ पे 0 है वो नेगेटिव नंबर एंड 1 फॉर पॉजिटिव नंबर. The following 8 bit represents exponent. The 8 bit is representing the exponent and the remaining 23 bit will represent the fraction. So consider the number shown in figure number 4.16. The sign bit represent the sign of the following number. If s equal to 0 then number is positive. If s equal to 1 then number is negative. In this example s equal to 1, hence it is a नेगेटिव. यहाँ पे देखो आपको ध्यान रखना है कि अगर s आपका 0 है, ठीक है, अगर s आपका 0 है तो पॉजिटिव नंबर, और अगर s आपका 1 है तो नेगेटिव नंबर. लाइक सपोज इन दिस एग्जांपल योर x is 1, that means this is the negative number. Here you can see this is the example is given below. सबसे पहला नंबर 1 है, so here your s means आपको पता है s का मतलब क्या है, s का मतलब साइन. So here you can see s equal to 1, that is single bit for sign. Then after e, exponent. What is the exponent? As you know, in the exponent 8 bit will become. So after that, whichever are the 8 bits, you have to take 1 0 0 0 0 0 0 1. This is your 8 bit exponent, and remaining 23 bits, that is your fraction in 23 bits. Remaining के जो numbers होंगे वो आपके क्या होंगे, that is the exponent, sorry, that is the fraction. Here you can see remaining 23 numbers like 0 1 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 and 0 0. यहाँ पे आप देख सकते हो 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 20 plus 3. This is the 23 digit. So this is the fraction. This is a fraction in 23 bit. So this is the example of number in IEEE format. So as you can see here that the exponent given here is 1 0 0 0 0 0 0 1 and b means binary. So यहाँ पे आप देख सकते हो आपका exponent क्या आया 1000,000,001. So the decimal equivalent of this number is 129 or 129D. ये देखो बाइनरी जो है, अभी बाइनरी को हमने डेसिमल में कन्वर्ट किया तो उसका आंसर क्या आता है 129 या फिर 129D. D means decimal. So in a normalized form the actual exponent is e minus 127. Actual exponent क्या है, it's a minus 127. Well, e is exponent given here, hence it is also called excess 127 notation. This is required to represent positive and negative number as exponent, that is hence, and here actually exponent is 129 minus 127, that is 2D. In the exponent here the actual exponent is e minus 127, but our here decimal equivalent of this number is 129 or 129D. So at the last here the actual exponent is 129 minus 127, that is 2D, means 2 decimal. Similarly the fraction is represented represented in a normalized form with a hidden 1.f form. The fraction given here is number is given. You can see the number here, like 23 digit has been given to you as in the upper table, as in the upper example. That is the actual fraction is 1.011, 4 times 0, 4 times 0, 4 times 0, 4 times 0, and 4 times 0 b. So the decimal equivalent form for this number, it is 1.1375 or 1.1375 d. So putting all these three components together, एक ही साथ हम तीनों को रखेंगे. So at the last we will get that minus 1.375 into 2 raised to 2 equal to minus 5.5 d, that is decimal. So consider the other example having representation. यहाँ पे देखो other example दिया है हमने टेबल में देखा IEEE का एक example. यहाँ पे another same example दिया हुआ है that 1. So that means it indicates the negative number, and here this is your 8 bit, that is exponent, and 23 bit, that is a fraction. So then equivalent representation in a decimal can be calculated as follow. Sign bit s equal to 1, that indicates the negative number. E exponent will be 0 triple 1 triple 1 0 b means binary, that equal to 126d, that means decimal in a normalized form. So the fraction is 1.1b with an implicit leading 1, it equal to 1 plus 2 raised to minus 1 equal to 1.5 d. So here you can see the number is minus 1.5 into 2 raised to 126 minus 127, that is minus 0.75 d. Moving to the next topic. Next topic is character representation. What is a character representation? Like in a computer memory, characters are represented using bit pattern. Group of 7, 8, 16 or 32 can be used to represent each character. Like कोई भी कैरेक्टर को रिप्रेजेंट करना है कंप्यूटर में तो पैटर्न के थ्रू रिप्रेजेंट होता है. A group of 7, 8, 16 or 32 bit. So the rule of determine such bit pattern in a specific length are known as an coding schemes. Historically, 7-bit American Standard Code of Information Interchange, that is ASCII code. That is ASCII code. 8-bit means American National Standards Institute, ANSI. It is ANSI code, and last is Extended Binary Coded Decimal Interchange Code, that is EBCDIC were used. यहाँ पे आप देख सकते हो कि कोई भी कैरेक्टर पैटर्न से स्टोर होता है कंप्यूटर में, उसके लिए किसका यूज होता है? ASCII का, ANSI and as well as EBCDIC का यूज होता है. So this coding schemes represented characters into 7 or 8 bits binary code. ये किस में रिप्रेजेंट होता है? into a 7 or 8 bit binary code. So in the next table, that is 4.3, let's choose the ASCII representation of सिलेक्टेड कैरेक्टर. मीन्स यहाँ पे देखो नेक्स्ट टेबल में आपको बताया है जो भी सिलेक्टेड कैरेक्टर है उसकी ASCII वैल्यू यहाँ पे रिप्रेजेंटेड की गई है यूजिंग द ASCII value, using the ASCII representation of the selected character. यहाँ पे देखो like suppose symbol 7, so the decimal is 55, 9, 57, colon 58, semicolon 59, less than 60, equal to 61, greater than 62, question mark 63, at the rate 64, A, B, C, D, 65, 67, 68. So this is the character represented into the ASCII वैल्यू। सो ये टेबल है, ये सब कैरेक्टर इसके थ्रू रिप्रेजेंट होते हैं थ्रू द ASCII वैल्यू। यहाँ पे टेबल में आप देख रहे हो, on the left hand side symbols has been mentioned, in the center decimal value has been mentioned, and in the right hand side binary value has been mentioned. So this is the table of characters which are represented into the ASCII. One can be represented maximum to 56 possible patterns using the size of 8 bits. So here you can see एक जो है one can be represented maximum 256 possible patterns using 8 bit। यहाँ पे एक कैरेक्टर को रिप्रेजेंट या फिर डिस्प्ले करना है तो उसके लिए 8 बिट का यूज होता है। वेर ईच पैटर्न रिप्रेजेंट एन स्पेसिफिक कैरेक्टर, हर कोई पैटर्न की एक स्पेसिफिक कैरेक्टर होता है। Hence, we may represent a limited number of characters. Further, this character scheme do not represent all the character into all the languages in a uniform format. So, presently, Unicode scheme is used to represent character into the computer memory. So, right now, in nowadays, which is going on, यूनिकोड स्कीम। यूनिकोड स्कीम अभी चल रही है, इसके लिए चल रही है फॉर रिप्रेजेंटिंग एनी कैरेक्टर इनटू द कंप्यूटर। कंप्यूटर में अगर कंप्यूटर मेमोरी में कोई भी कैरेक्टर रिप्रेजेंट करना है तो अभी कौन सा चल रहा है? राइट नाउ यूनिकोड स्कीम इज गोइंग ऑन। उससे पहले कौन सा था? आस्की था। So this Unicode provides universal and efficient character. यूनिकोड मीन्स यूनिकोड का मतलब क्या है? यूनिकोड क्या प्रोवाइड करता है? इट्स एन यूनिवर्सल एंड एफिशिएंट कैरेक्टर टू प्रेजेंटेशंस and hence involved as modern character representation scheme also. So Unicode scheme is developed and maintained by a non-profit organization called Unicode. Unicode scheme is developed and maintained by a non-profit organization called Unicode Consortium. Consortium means grouping, Unicode grouping. So here you can see that this Unicode is also compatible with other coding scheme like ASCII। यहाँ पे आप देख सकते हो यूनिकोड स्कीम इसके थ्रू डेवलप एंड मेंटेन हो रही है थ्रू ए नॉन प्रॉफिट ऑर्गेनाइजेशन दैट इज यूनिकोड consortium. It means a grouping. And also here you can see Unicode is incompatible under with other coding like scheme like ASCII. In Unicode, use either 16 or 32 bit to represent a character। यूनिकोड में कोई भी आपको कैरेक्टर रिप्रेजेंट करना है कि किसके थ्रू कैरेक्टर रिप्रेजेंट होता है हम नहीं कर सकते ऑटोमेटिकली। किसके थ्रू कैरेक्टर रिप्रेजेंट होता है? टू द 16 और 32 bit। And the Unicode has a capability to represent characters from all the major language across the world। यहाँ पे यूनिकोड में कैपेबिलिटी है कि in all the languages across the world they can mention the character। The 16-bit Unicode scheme allows 64K, that is 65,536 unique patterns, and that is it can represented by 65,536 characters uniquely। सबकी आइडेंटिटी यूनिक होती है उसमें। And further 44,949 more characters were added into this scheme in May 2001। यहाँ पे पहले ऑलरेडी 65,536 कैरेक्टर तो थे, उसके बाद और कैरेक्टर ऐड हुए कितने? 44,949। कौन से साल में? इन द मे 2001। दिस कैरेक्टर were from any language: Chinese, Japanese, Korean language and culture। So right now presently the Unicode latest standard is 32 bit। Unicode का latest standard कितना है? It's of 32 bit। And can represented more than 1 lakh characters unique pattern in a unique pattern. यूनिकोड है वो 1 लाख से भी ज़्यादा कैरेक्टर रिप्रेजेंट कर सकता है यूनिकली. In the next table, you will see some examples. You can see here Unicode on the left hand side. You can see Unicode number in the center. You can see the character, which character it's storing, and in the right hand side you can see the description. So here you can see that Unicode U plus 0030. That means this store 0 digit 0. ये क्या स्टोर करेगा? 0 digit स्टोर करेगा. Like 31 है, like U plus 0031 that stores digit 1, U plus 0032 that stores digit 2. So here you can see this is the table, different Unicode stores the different character. Like you can see here U plus 003E that stores a greater than signature. U plus 0041 that store a Latin capital letter A. So this is the table of Unicode and which character is storing. So this is the Unicode character formation. Next topic is image representation. Image representation in the computer memory. कोई भी इमेज है वो कैसे रिप्रेजेंट होती है कंप्यूटर मेमोरी. अभी भी आप स्क्रीन पे देख रहे हो कि यहाँ पे एक पीडीएफ ओपन है. आप अभी इमेज देख रहे हो तो ये भी कैसे स्टोर हुए, किस में स्टोर होती है. तो इमेज रिप्रेजेंटेड इन ए कंप्यूटर मेमोरी इज कॉल्ड ए डिजिटल इमेज. जो भी इमेज कंप्यूटर में होती है उसको हम क्या बोलेंगे? दैट इज नोन एज एन डिजिटल इमेज. एंड the reason behind this is that the image is ultimately converted into sequence of zeros and ones for its possible representation into the computer memory. One way to describe an image using digits is to describe its content using positions and size of geometric forms and shapes such as line, curves, rectangles, and circles. Such representations is called vector image representation. Like देखो, जो कोई भी image like कोई भी size से create कोई हुई हो, like which form which using of shapes such as line, curves, rectangle, circle. So this type of such a representation are known as a vector image representation. A vector image can be easily enlarged and shrunk without affecting the क्वालिटी ऑफ द इमेज. इसमें इमेज क्वालिटी में कुछ भी चेंज नहीं होता है. वेक्टर इमेज आर प्रिफर्ड वे टू रिप्रेजेंट फोन्स, लोगोज एंड मैनी illustration. Another way to represent an image into a computer memory is dividing the image into fixed number of rows and columns. यहाँ पे देखो और एक वे है जिससे इमेज स्टोर होती है. Like in that there is a fixed number has been kept of rows and columns. Like each cell intersecting of rows and columns is known as a pixel. That is picture cell. Each pixel represents a value that represents the brightness of a given color at any specific point. If you divide the image into more number of rows and columns, very fine information about the image can be stored and hence quality of the image is increased. The set of pixels normally is formed of two-dimensional array and is stored in image memory as a raster image or raster map. यहाँ पे देखो लाइक सेट ऑफ पिक्सल्स जो होते हैं वो नॉर्मली कौन से फॉर्म में होते हैं? इन ए 2D. दैट मीन्स टू डायमेंशनल एरे एंड इट इज स्टोर द मेमोरी एज एन रेस्टर इमेज. इसको हम क्या बोलेंगे? ये सब इमेजेस को हम रेस्टर इमेज या फिर रेस्टर मैप. टू इम्प्रूव क्वालिटी ऑफ इमेज वी रियली नीड टू स्टोर हाई अमाउंट ऑफ डेटा इनटू द कंप्यूटर. लाइक जैसे उसकी साइज बड़ी होगी वैसे इमेज क्लियर होती है आपकी. So an image that is of 2048 pixels in width and 1536 pixels in height has a total of 2048 multiply 1536, that is 314578 pixels or 3.1 megapixels megapixels, one could refer to it as 2048 by 1536 or 3.1 megapixel image. You might have observed that some phones and digital camera with a specification such as 3.1 megapixels. That means the image taken by the camera has the resolution of this much. So this term resolution is often used of picture count in a digital image. यहाँ पे देखो आपको एग्जांपल बताया लाइक you can see 3.1 megapixel of camera, 3.1, 3.5 and many more. So इसका मतलब क्या होता है that means 2048 multiplied by 1536 resolution image size is there. Many times it is difficult to deal with such a bundle of data. An image take a significant amount of memory to store all pixels. Sometimes क्या होता है कि bundle of data can be stored in your phone. ज़्यादा image होती है, ज़्यादा दूसरे files होती है. So and we must remember that we may have a stored number of image into the computer. This problem becomes even harder to manage when we try to send such a bunch of image via computer network. To avoid such memory management and image transferring problem, images are often stored and transferring in a compressed form. Like for raster images, here you can see some of the format which are the popular, that is dot BMP, that is bitmap image, JPG, joint photographic exports group, PNG, portable network graphics, GIF means graphic interchange format and TIFF that means tag image file format. So यहाँ पे आप देख रहे हो raster image की format सब यहाँ पे describe की गई है. Just like images, audio and video information is also represented as digital information into computer memory. जैसे आपको पता है कि image को हम digital image बोल सकते हैं. So as like that, storing of audio, video, image and this type of information is also represented as a digital information. इसको हम क्या बोल सकते हैं? This is known as a digital information into your computer memory. So computer represents sounds as a binary number. For this parameters such as frequency and resolutions are considered. आप सबको पता है कि जो कंप्यूटर रिप्रेजेंट करता है साउंड वो किस में शो में मेंशन करता है ना बाइनरी number. So for this they are using a parameters such as frequency and a resolution which are considered. So this sound and audio file have formats like WAV, MP3, window media audio. So this type of extensions are there of the sound media. ये जो sound media होते हैं उन सब के formats होते हैं like WAV, that means waveform audio file format. .mp3 means moving picture exports group, and WMA, that means video media audio. And also digital video is a type of digital recording system that work by using a digital rather than a analog video signal. Digital video consists a sequence of digital image displaying in continuous fashion at a constant rate. यहाँ पे देखो डिजिटल वीडियो अगर कोई चल रहा है तो आप देख सकते हो उसमें दैट कोई भी इमेज डिस्प्ले की हुई होती है और continuously it is displaying in a fashion of the constant rate. This image are identified as a frame. ये इमेज कैसे आइडेंटिफाई होती है? थ्रू द फ्रेम. In a secondary, typically more than 45 frames must have to be passed to generate effect of a continuous scene. However, earlier silent film had frame up to 25 to 30 per second. So this type of popular video file formats like FLV, that means flash video format, AVI, that means audio video interleave, WMV, that means Windows Media Video, And the last is MP4, that is Moving Picture Experts Group. So right now you all are seeing that whatever we are seeing the video, that all our videos are kept in the MP4 format. So here our lesson number 4 is completed. So students, today's your homework is the टेक्स्ट बुक MCQ. टेक्स्ट बुक में जो MCQ है वो आपको सॉल्व करने हैं अपनी नोटबुक में. Here you can see there is a 13 MCQ is there. 13 MCQ आपको सॉल्व करने हैं होमवर्क में. ऑप्शंस लिखने की ज़रूरत नहीं है. Just you can write the question and correct answers. You can also see the previous video link for solving this MCQ. Thank you everyone.